Hi everyone. In this video, we're going to talk about neighbor discovery protocol in IPv6, which is equivalent to ARP in IPv4. Now, I have already made a video on how ARP works in case of IPv4. I would highly recommend that you watch that video first before going through this video so that you can develop a better understanding of how this protocol works, what are the similarities, what are the differences. With that, let's try to understand why we need neighbor discovery in IPv6. What is the problem it is solving? Let's say you have 3 hosts here, for example. This can be again any PC or servers, whatever. They are connected by some network, which can consist of routers, switches, hub, whatever. And let's say host 1 has this IPv6 address, which is the link local address. As you can see, FE80 link local address starts with FE80. Similarly, host 2 has its own link local address, and the interface on host 3 also has the IPv6 link local address. Now, the requirement is that host 1 wants to talk to host 2. Host 1 wants to send some packets to host 2. Now, host 1 will have the IPv6 address of host 2, which is right here, the FE80 ending with F083. However, it would need one more piece of information to talk to host 2, which is the MAC address of host 2. Now, Neighbor Discovery Protocol helps in getting the MAC address of host 2 if we know the IPv6 address of host 2. This is the problem Neighbor Discovery Protocol is trying to solve. Now, let's try to understand how exactly it achieves this. So, Neighbor Discovery Protocol makes use of two of the ICMPv6 packets. One is the neighbor solicitation packet, and the other packet is called neighbor advertisement packets. I'll give you more description. I'll show you in the packet capture how these packets look like. But before that, now let's say host 1 wants to get the MAC address of host 2. What host 1 does is it sends the neighbor solicitation packet saying, hey, what is the MAC address of this particular IPv6 address? Now, one interesting thing to note here is that destination IPv6, in case of neighbor solicitation, in the neighbor solicitation packet, would be a solicited node multicast IP. This was not the case in IPv4, the ARP in IPv4. When we are doing ARP in case of IPv4, it was a pure layer 2 frame, and the destination MAC was a broadcast MAC address, all F. In case of IPv6, it is a layer 3 packet which has the IPv6 headers, and the destination IP is not a broadcast one. We don't have broadcast in IPv6. It is a multicast IP. We call it the solicited node multicast IP. This is one really nice optimization. I'll talk about that, how it optimizes, how it brings optimization in case of IPv6. So please understand, so the destination IPv6 is solicited node multicast IP. I'll talk more about what exactly it is, how it brings the optimization. How do you find out the solicited node multicast IP for any host towards the end of the video. So, okay, so it has this destination IPv6. Now, it means this node solicitation packet would be received by all the hosts which are subscribing to this solicited node multicast IP. Now, this is where the optimization comes in picture. In case of IPv4, it was broadcast MAC, so it would be received by each and every host in the broadcast segment. Whereas in case of IPv6, it would be received only by those hosts which are subscribing to this solicited node multicast IPv6, not all the hosts in the broadcast domain. Yeah. So after that, what would happen is all the hosts which have subscribed to those solicited node multicast IPv6 would receive, and they would open up the packet, and they would see what is the target IP in the neighbor solicitation packet. And only among all those hosts, only the host whose IPv6 matches the IPv6 in the target IPv6 address in the neighbor solicitation packet, only that host is going to respond with the packet called neighbor advertisement packet. Now this would be a unicast back to host 1, the host which had sent the neighbor solicitation. Now this way, the host 1 would get to know about the MAC address of host 2. Now, as I told, I'm going to talk a bit more about solicited node multicast IP. So here is how it is calculated. Now this is the standard prefix FF02 : 1 FF000/104. This is the standard prefix which is used to calculate the solicited node multicast IP. Now let's say you have a host whose IPv6 looks like this. Okay. Now I want to find out which solicited node multicast group it would subscribe to. Now, if I want to find out that, what I would do is I'll take the last 24 bits from this IPv6 address, which would be 25:F083. This is in hexadecimal format. So every digit, what you see is 4 bits. Okay. So here we have last 24 bits of the IPv6 address. And then we take the standard solicited node standard prefix used to generate this solicited node multicast IPv6, and we append this too. So what we would get is this particular multicast IPv6, which is FF02: 1, and then the last 24 bits matches the last 24 bits of this IPv6. Now this is the solicited node multicast IP for this particular IPv6. What it means is this particular host, which has this particular IPv6 on one of the interface, would subscribe to this solicited node multicast IPv6. It means any packet whose destination IPv6 is this solicited node multicast IPv6, this packet would be received by this host. So if there is any other host in my segment whose last 24 bits are same, then the neighbor solicited packet, which we talked about in the previous slides, those packets would be received by all those hosts whose last 24 bits match this, but not by each and every host in the broadcast domain. It means I'm not going to flood out the neighbor solicited packet to each and every host. Rather, I'm going to multicast it to only the host whose last 24 bits match. There is one optimization which we see in case of IPv6, which is not there in IPv4. I hope that makes things a bit clear. Now, let's see how the neighbor solicitation packet would look like, which is sent from host 1 to as a multicast packet. So if you see, the source address would be is a link local address here, which is the link local address of host 1, and the destination address you see here. This is the solicited node multicast address, which is generated from the target IPv6. Remember, the target IPv6 is basically this IP. for which I want to know the MAC address. So I take this IPv6, I take the last 24 bits, 25 colon F083, put it on the standard prefix used to generate the solicited node multicast IP here, and then I generate this multicast address. So this is the destination IP of my neighbor's solicitation packet. Now this would be received by all the hosts whose last 24 bits are this. Okay. Now this host would receive the IPv6 packet, they would extract it, they would see what is the target IPv6 address, and only the host, in this case, which is host 2, IPv6 address matches this IPv6 address. So host 2 is going to reply with neighbor advertisement packet. You see here, the source address is this. This is technically host 2's IPv6 address. This is going back to host 1. So this is a unicast now. Now here it says the target address, which was the host 2's IPv6 address. Okay. This is the link layer address for that IPv6 address, which is what host 1 wants. So as soon as host 1 receives this neighbor's advertisement packet, it understands what is the MAC address for host 2's IPv6 address, and it populates its neighbor cache, and it can now send the packets to host 2. Now, this is the fundamental difference between ARP in IPv4 and IPv6. So as I already mentioned, ARP in IPv4 is pure layer 2 protocol. It does not have the layer 3 headers, the IP headers. It has only layer 2 headers, and the destination MAC address is all app broadcast. Whereas in case of IPv6, the neighbor discovery protocol, it is a layer 3 protocol. It means it would have the layer 3 headers, which is basically IPv6 headers. And the destination IPv6 in this case would be a multicast instead of broadcast MAC, which we had seen in IPv4. So this is where we achieve the optimization in IPv6. Now let's jump to our lab and see how this packets look like in real network. Now here I have simulated a network which consists of 3 PCs, just like I showed you in the previous slides. Now these are the IPv6 addresses. Host PC1 has this IPv6 address, PC2 has this, and PC3 has this. Now what I'm going to do is let me go to PC1. No, they're all connected via this hub. Okay. Let me go to PC1. Okay. So now IP address here, you see on the E0, this is the IPv6 address of PC1. Similarly on PC2, this is the IPv6 address, and I'm going to ping to this particular IPv6 address. And this is the IPv6 address of PC3. Now let's look the neighbor cache, which is empty right now on PC1. On PC2 as well, it is empty. Now what I would do is let me start the packet capture first. Here we go. Okay, start capture. Okay, so I have started the packet capture. Let me go to PC1. Let me go to PC2, copy its IP address, which is this IPv6 address. And I go to PC1, and what I do is ping 6. Let me send out 2 packets. And this is the IPv6 address, reachable via 0. Now I see the ping is successful. Let's see how it is learning the MAC addresses for this particular IPv6 address, which is the IPv6 address of PC2. Now, if I go back to my capture, you see here we have the neighbor solicitation, which is equivalent to ARP request in case of IPv4. Now you see here the source IPv6 address. Let me expand it. Source IPv6 address ending with C57C is host 1's IPv6 address. You see here. host 1 ending with C57C. Okay. Okay, sorry, I had selected a different packet. Yeah, so I'm selecting the first packet, which is the neighbor solicitation packet. Now, if I see the source address, source IPv6 address, this is ending with 97AC, which is 97AC. This is the IPv6 address of PC1. And now, if you see the destination IPv6, this is the solicited node multicast IPv6. And if you see last 24 bits, which is 9C, C57C, which matches the IPv6 it's trying to ping. This is what is the IPv6 which we are trying to ping. And these are the last 24 bits. From this, we have generated the solicited node multicast IPv6. Okay. Now, if you see the target IPv6 address in this case would be this particular IPv6 address, which belongs to host 2. Now, this solicited node this neighbor solicitation packet would be received by all the hosts whose last 24 bits are this. Okay, whose last 24 bits in the IPv6 address are this. Now, because host 2's IPv6 address matches exactly with the target IPv6 address, which is this, only host 2 is going to reply with the neighbor advertisement packet, which is what we see here. Okay, if you see here, this is the source is host 2's IPv6 address ending with C57C. This is PC2 ending with C57C. This is the IPv6 address of PC2. And this is the IPv6 address of PC1 ending with 97AC. 97AC. Yep. Here we go. PC1 97AC. Okay. So this is the neighbor advertisement packet, which is a unicast, as you can see. Now, if you scroll down here, so the target address was the IPv6 address ending with C57C, and this is the link layer address, the MAC address, which belongs to this particular IPv6. So this is the MAC address of PC2. So let's see, C57C. So PC2, if I see it's 0, it ends with C57C. So this is the MAC address of PC2. So the moment PC1 receives this advertisement message, it knows what is the MAC address of PC2 and it populates its neighbor table. So here you see, this is the IPv6 address of PC2, and this is the MAC address of PC2. So, and once it has the MAC address, the ping would go through, as you can see here. The ping is working fine from PC1 to PC2. This is the request, this is the reply. Okay. So that's pretty much it for this video. I'm going to talk more about, I'm going to make some more videos on some more topics of IPv6. For example, how, if you would see, there's a lot of similarity between the MAC address and the IPv6 address here. You see the 97AC, here also it's 97AC, then you have F3, here also you have F3. So how this IPv6 address is generated from MAC address, that's a topic for another video. I'm going to talk more about that. I'm going to talk also about duplicate address detection and other topics on IPv6. So thank you so much for watching this video. If you have any questions, feel free to put your questions on the comment box. I'll try to address those. Thank you so much.